All right, let's just jump right in. We all know that large language models are, well, incredibly powerful, but they have this one fundamental problem, right? How do we make them more reliable, more accurate, and how do we make them knowledgeable about the world as it is right now, not months or even years ago when they were trained? That's the huge challenge we're going to unpack today.
But here's the thing. The most promising solution to this whole problem, this technology called RAG, is itself, well, flawed, according to some of the top experts out there. So what is going on here? Why is the supposed fix in need of its own fix? That's the puzzle we're going to piece together.
You know, to really get why the solution is so important, we first have to appreciate the problem itself. Because at their core, even the smartest AI models have these limitations that feel, honestly, surprisingly human. And these are the exact issues that RAG was built to solve.
When you really look at these core limitations, they probably feel pretty familiar. First up, you've got hallucinations. That's when the AI just confidently makes stuff up. Second, its knowledge is totally static. It's literally a snapshot in time. And finally, it knows absolutely nothing about your company's private data or anything that's happened since its training date. It's basically operating out of a locked, sealed library. And look, this isn't just some small technical quirk. It is a massive business problem. A 2024 survey dropped this number. 50%. 50% of organizations said that just evaluating if their AI is working correctly is their second biggest challenge. So when half the industry is struggling to even trust their AI, you know you've got a problem that needs a real solution fast.
And that brings us to the hero of our story, Retrieval-Augmented Generation, or RAG for short. You can think of it as giving the AI an external brain, a direct line to a library that's always updated and full of specialized info. Really, it's about changing the AI from a static know-it-all into a dynamic learn-it-all.
The idea is actually pretty brilliant in its simplicity. Instead of forcing the AI to just guess an answer based on its old training data, RAG makes it look up the answer first. It's the difference between a closed book test and an open book test, and it makes sure the answers are based on fresh, factual information.
So let's just break that down a bit. A standard LLM tries to answer you from memory, and memory alone. But an LLM with RAG, it looks up the answer first in a knowledge base that you provide. Could be your company's internal documents, the latest news articles, a medical database, whatever. And then it uses that fresh info to build its response.
Okay, so how does this whole lookup process actually happen? Well, the most basic version, what the experts call naive RAG, follows the surprisingly straightforward three-step process to get you from a simple question to a grounded, intelligent answer. So it all starts with indexing. The system takes all your documents, chops them up into these bite-sized chunks, and then turns them into numerical vectors. It's basically creating a super searchable digital library. Next up is retrieval. When you ask a question, the system instantly searches that library and finds the most relevant chunks. And finally, generation. The AI gets your original question plus those relevant chunks of info, and it uses all that fresh context to build a factually grounded answer. And this view here really pulls it all together. It all starts when a user asks a question. That question triggers the retrieval process, which pulls the most relevant documents, those chunks we talked about, from that database up top. Those chunks are then mixed in with the original prompt and sent off to the LLM. And the result? A much more informed, way more reliable answer. It's a simple loop, but it's incredibly powerful.
But if this so-called naive RAG is so simple and powerful, where does it fall short? And this takes us right back to that quote from the beginning that pure RAG is flawed. And that is exactly why the entire field has been moving towards more advanced, more intelligent RAG systems.
And you can literally see the evolution right here. On the left, you've got that simple, straight-line flow of naive RAG we just talked about. But then on the right, you see advanced RAG. Now, don't worry about all the new boxes just yet. The key thing to notice is that it's no longer a straight line. It's adding new, smarter steps like re-ranking the results or even rewriting the query to make the whole process way more intelligent and adaptive.
A fantastic example of this is something called corrective RAG, or CRAG. With this, the system adds a self-correction step. It retrieves some documents, and then it actually grades them for relevance. If the documents are no good, it basically says, nope, this isn't right, and it triggers a web search to find better information before it even tries to generate an answer. It's RAG with a built-in quality check, which is just absolutely critical in high-stakes fields like medicine or finance.
And then you've got self-RAG, which takes this whole idea even further. I mean, this is a system that can start to think for itself. It adaptively decides if it even needs to go look for information. It has a built-in self-critique mechanism, so it can evaluate how relevant its retrieved data is and if its own answers are factually supported. It even comes up with multiple possible answers and picks the best one.
It's just a much more autonomous, reflective process.
Okay, so we have all these increasingly sophisticated systems, but that brings up a really critical question. How do we actually measure their performance? How do we know if our shiny new advanced RAG is truly any better than the basic one?
Well, this is where we have to put on our lab coats and become scientists. To really know if it's working, we have to measure it against some key metrics. We have to ask, is it faithful? Meaning, is it sticking to the facts it found, or is it hallucinating? Is the answer relevant to my actual question? And did it have good context recall? In other words, did it find all the info it needed to give a complete answer? Without measuring these, you're just flying blind.
Now, everything we've discussed so far has been about text, but the world we live in isn't just made of text, right? So the truly exciting frontier for RAG is moving into the realm of sight and sound, getting AI to understand the world a lot more like we do.
This is Multimodal RAG. It's a system that's designed to process and reason over everything all at once. Video feeds, audio clips, text documents, you name it. It doesn't just read a report, it watches the security camera footage and listens to the conversation to get the complete picture.
This example really shows off its power. So, the system sees the Statue of Liberty in the video, but it hears a conversation about going to the Brooklyn Bridge instead. By combining both sight and sound, it can figure out the actual plan. I mean, this is a huge leap into true situational awareness, something a text-only system could never even dream of.
So when you put it all together, you can see how RAG fundamentally changes what an AI is. It transforms the model from a static know-it-all that's trapped by its old training data into a dynamic learn-it-all that's capable of engaging with the world as it is right now.
Which leaves us with one final, pretty provocative thought. As these systems keep evolving, from simple text lookups to full multimodal understanding, they get closer and closer to being able to access and reason over all of human knowledge in real time. So what does that kind of capability truly mean for the future of work, for discovery, and for the very idea of expertise itself?